Hello, in this series of recordings we're going to talk about Module 3, where we will discuss descriptive measures of the frequency distribution of a numeric variable. Alright, the objectives for this module is that, the expectation is that by the end of this module you should be able to distinguish between a parameter and a statistic. You should be able to list measures of centrality and their advantages and disadvantages, list the measures of dispersion and their advantages and disadvantages, determine the proportion of observations within an interval about the mean, list the measures of position and be able to explain their meaning, explain the construction of a box plot and be able to explain what it represents, and then explain a graph that is comparing two box plots. So we'll go through all of this. All right, the very first thing I'd like to talk to you is about parameters and statistics. And this is in the text, you will find it in the subsection 3.24. I'm discussing this first because I think it's very important to make this distinction right from the beginning before we can start talking about the parameters or the summary statistics. All right, so I'd like to go back to Module 1 where we talk about the inferential statistics. And you may remember that inferential statistics is where we use a sample result to make inferences, that is, make decisions or predictions about a population. So in this definition, we're listing both the statistic and the parameter. So when we say we're going to use the sample result is called a statistic. And when we say we're going to make an inferences, that is a decision or prediction about a population, we are referring that we're making a prediction about the population parameter. And that's why it's so important to make this distinction right up front, because as I mentioned, I think in Module 1, starting with Chapter 4, we're going to start preparing everything to talk about inferential statistics. So it's very important to make this distinction. All right, here's an example. In this example, our objective is to estimate the average weight of all pre-K children in San Antonio. And this comes from a consulting job that I had with a physician here in San Antonio. And the interest in that situation was to evaluate the average weight of all the pre-K children in San Antonio. That's what we have in this group right here. And as you would imagine, it could be very expensive, very time-consuming, and sometimes impossible to evaluate every children in the San Antonio schools that are at the pre-K, in the pre-K program. So what we do, we select a representative sample. Then once we have that's a smaller number of children that represent the population, then we weight them. Then we use all their weights to calculate the sample mean, which is the statistic. Then we're going to use that sample mean to estimate the population mean of weight, which is the parameter. And later on, we will learn as to how to make this estimation based on the statistic, or estimation about the population parameter based on the statistic. But as you can see, this represents a cycle of the statistical inference. And again, is based on using a sample, using the sample statistic and making an inference about a population parameter. Now, now that we have talked about the statistic and the population, let's come back to what we learned in Chapter 2. In Chapter 2, we learned how to create a frequency distribution. And we use the frequency distribution to create the histogram, which is how we summarize a frequency distribution of a numeric variable. Now, these frequency distributions are characterized by three types of measures. The measure of location, that tells us where the center of the distribution is. The measure of dispersion, that tells us how variable the data is or how dispersed it is. And the third one is the measure of the shape of the frequency distribution. So we're going to be dealing with three types of statistics and three types of parameters. But remember, we have three types: the measure of centrality, the measure of dispersion, and the measure of shape. All right, in this table, I wanted to summarize all these characteristics of a frequency distribution. Under central tendency, we have three measures: the mean, that probably you're familiar with, the median, and the mode. In terms of dispersion or variability, we have four measures: the variance, the standard deviation, the range, and the interquantile range. In terms of shape, we have two measures: skewness and kurtosis. Now, if you notice here in these last two columns, I'm writing the classical symbols to designate these measures. For example, if you are talking about the mean of the population, that is the parameter, we're going to use the Greek letter mu, M-U. Whenever you write mu, you're saying that you're talking about the mean of the population. However, if you write X bar, that means you're talking about the sample mean. If you use mu tilde, then that means that you are referring to the median of the population. If you use X tilde, that means that you are referring to the median of the sample. And this is very important because from now on, we're going to be making this distinction. So when you say the median is 25, I say, well, the median of what? Are you talking about the parameter or the statistic? So we're going to be very specific. And we're going to say, are we talking about the parameter or the statistic? And the symbol that we use will tell us exactly what we're working with. The mode is not common and is not used very often, so there is not a specific symbol for it. So I just put mode in both cases. Now, in terms of dispersion, the two most common measures are variance and standard deviation. So for variance, we use the Greek letter sigma and square. So if you write sigma square, then I know you're talking about the variance of the population. So this is a parameter. If you write S square, then that's the variance of the sample. So now this is a statistic. Okay. Now, the standard deviation is just the square root of the variance. That's why we write sigma. So if you write the letter sigma, then I know that you are talking about the population standard deviation. That's a parameter. If you use the letter S, again, the standard deviation is the square root of the variance. And so if you write S, then I know that you are referring to a sample statistic. And that's the standard deviation of the sample. Again, range is not used very commonly, so I put R, the same for the interquantile range. I use the common symbol, which is IQR, and it's rarely that someone makes a distinction between the population and the sample. All right, and now in terms of shape, we have skewness. Usually we use the letter alpha 3. And for the parameter, so that's the skewness of the population, we will use alpha 3. And the skewness of the sample, we will use the letter A3 or A sub 3. And if we talk about kurtosis, we use alpha 4 sub 4, and that's for the kurtosis of the population. If you're referring to the kurtosis of the sample, then we use A sub 4. Now, let me be clear here. In this course, we're not going to be discussing skewness and kurtosis. If you're interested, let me know. I can give you some references where you can find more about this. And what I like you to notice is that whenever we talk about population parameters, we're using Greek letters. And whenever we talk about sample statistics, we tend to use lowercase Roman letters, as you can see. So again, this table is very important because it tells you the different measures of centrality, the measures of dispersion, measures of shape, and the symbols that we use to designate the parameter and the statistic. So given this knowledge, now we can start talking more in terms of symbols and figures that I think at this point you're familiar with. So again, we have a population. We take a sample. From that sample, we calculate statistics, which are calculated from the data. So when you say a statistic, that is a characteristic of a sample, and it's calculated from the data that you obtain. In here, in this diagram, I'm showing you three characteristics. The histogram, which tends to, or is trying to tell us what is the shape of the data in the sample. And we have X bar that tells us what is the average of the data in the sample. And we have S, which tells us the standard deviation of the measure of variability of the data in the sample. Now we're going to use all these three characteristics, shape, location, and dispersion, to make an inference about the population characteristics, which are the parameters, which are the population characteristics. In this case, we're going to try to infer what is the frequency distribution of the population, what is the mean of that frequency distribution, and what is the standard deviation of that frequency distribution. And if you notice, I use mu and I use sigma, because these are population parameters. So you're going to see me throughout the course start referring to these quantities by their correct symbols. So please pay attention to the symbols, because they are very important in how we communicate from now on. All right, so at this point, it should be clear in your mind what is a parameter and what is a statistic. I'm going to stop here, and then in the next segment, we're going to talk about the measures of central tendency.